Hi, my name is Sujal and I am the team captain for Group 3 for this CYT300 capstone project. In this video, I will be presenting our project update. I will cover our project overview, system design, technical implementation, and current project status, including our challenges and next steps. So let's get into it. So here is a quick overview of what we will cover. First, the project overview, what we are building and why. Second, system design, our architecture and virtual lab. Third, technical implementation, what tools we are using and what we have done so far. And fourth, the project status, the challenges we faced and our next steps. Let me start with the problem we are solving. Our simulated client is a MapleGuard Technologies, a mid-sized software and data services company based in the Greater Toronto area. The problem is the MapleGuard's current security posture is completely reactive. First, their incident response time is anywhere from 4 to 24 hours. That is a very long window for an attacker to move through a network undetected. Second, they have a zero automated threat detection or correlation. Their analysts are doing everything manually, which leads to alert fatigue and missed indicators. Third, their overall posture is reactive. They have no proactive defense, no structured way to track incidents, and no threat intelligence pipeline. This leaves them highly exposed to attacks like phishing, credential theft, lateral movement, and ransomware. This is exactly the problem our CTI framework is designed to fix. Here are objectives and what we expect to deliver at the end of this project. Our objectives are implement four key tools: MISP, TheHive, AlienVault OTX, and MITRE ATT&CK in an isolated VMware virtual lab, reduce MapleGuard's mean time to detect threats under 30 minutes, automate threat correlation so that when a threat indicator is matched, an incident case is created automatically, and validate the entire framework against a real scenario that we designed, which is called Operation Silent Invoice. Our expected outcomes are: the final goal is a full working CTI framework across all four tools in a verified lab environment. We also expect to deliver a working MISP to the Hive integration with OTX threat fits, attack scenario validation and evidence, and full compliance alignment with NIST CSF version 2.0, PIPEDA, and SOC 2. Everything runs inside a VMware Workstation virtual lab. All 5 VMs are on a host-only network. This means they are fully isolated from the internet and from any production system. Uh, they can only communicate with each other. We have 5 virtual machines. The first is a Kali attacker. This simulates the threat actor in our attack scenario. The second is Windows endpoint. This is simulated victim machine inside MapleGuard's network. The third is the DMZ server. This represents a public-facing server target. The fourth is the MISP server. This is our threat intelligence platform where we store and correlate indicators of compromise. And the fifth is the Hive server. This is our incident response and case management platform. The workflow goes like this: AlienVault OTX feeds external threat intelligence into MISP. MISP correlates that with internal indicators. When there is a match, MISP pushes an alert to the Hive, which automatically creates an incident case. A security analyst then logs in, review the case, investigates the observables, things like IP address, domains, and the file hashes, and documents their findings. MITRE ATT&CK sits across the entire framework. Every stage of the attacker's behavior is mapped to a technique, so analysts always have context for what they are saying. Here is the IP address table for our lab. Kali attacker is at 135. Windows endpoint is at .134. DMZ server is at 1.133. MISP server is at 131, and the Hive is at 132. All 5 are on the 192.168.95.0 subnet. This was all confirmed during our milestone 6 network testing. All connectivity tests passed with zero packet loss. For our tools and technologies, we are using VMware Workstation Pro for virtualization. Our attacker machine runs Kali Linux with XFCE. Our 3 Linux servers run Ubuntu Server 24.04 LTS. Our endpoint runs Windows 10 Enterprise. For the CTI stack, we are using MISP for threat intelligence management, AlienVault OTX for external threat feeds, TheHive 5 for incident response, and MITRE ATT&CK Navigator for behavior mapping. For network testing, we used Nmap and standard ping. Now let me walk through what we have actually completed so far. Number one, all 5 virtual machines are built and running in VMware. I want to be clear here, all 5 VMs are online and running at the OS level. Application level installation for MISP and TheHive is planned for the next phase. I will talk more about that in a moment. Number two, network connectivity is fully verified. From the Kali attacker, I ran ping test to all 4 other VMs, and every single one returned zero packet loss. The lab network is working correctly. Number three, our requirements are fully documented. We have 15 functional requirement, 15 non-functional requirement, and 11 CTI framework features, all mapped in a traceability matrix. Number four, um, our attack scenario is already designed. Operational silent invoice is a phishing to ransomware chain that we will use to validate the framework. It covers 5 stages: phishing, credential theft, lateral movement, command and control, and ransomware. And the CTI framework is designed to detect and stop it within 30 minutes. Number five, the Hive configuration planning is complete. We have documented the port, users, cases, tasks, observables, and dashboards. The planning work is done and ready for implementation. Now let me show you a live demonstration of where we are. Let me show you the live demonstration. Here are all our 5 VMs, the Kali attacker, the Hive server, MISP server, TMZ server, and the Windows endpoint. All are properly installed and configured with host-only network. Now I'll start by showing our network connectivity. So I am now pinging the MISP server from our Kali at 0.131 IP for the MISP. So it shows 0% package lost for receipt and for sent, which means that it is MISP is reachable from our Kali. Now let's test our TheHive server. And yes, again 0% packet loss. So similarly, all the VMs are communicating correctly on the host only network. And this is our TheHive server. The host name is the Hive server, and IP is also the same, ending with 1.132. And now let me check the application status. So it is active and running. So it was successfully installed. Also with this dependency, which are Cassandra and Elasticsearch, after resolving many compatibility issues with Ubuntu 24.04. So now let's get back to Kali on our browser and navigate to the TheHive login. So and here is the Hive login page, fully accessible from our Kali through our host only network. This confirms that the application layer is working, not just only the VMs and network layer. So let's log in. So I just have logged in, and here is the TheHive dashboard. This is where the analyst will manage their incident cases, tasks, and observables once the full CTI pipeline is connected. Now let me talk about the challenges we encountered during this milestone and how we addressed them. Challenge 1: resource constraint. Running 5 virtual machines simultaneously is very demanding on RAM and storage. Elasticsearch alone was consuming over 1.2 to 1.3 gigabytes of swap memory, which was causing out of memory crashes. We fixed this by limiting Elasticsearch heap size to 256 megabytes, which reduced the memory pressure enough for TheHive to start and stay running. We also used VMware snapshots during the process, so we never had to redo the setup from the scratch. Challenge 2, the Hive installation and dependency conflicts. This was our most complex challenge. Ubuntu 24.04 had compatibility issues with the standard Cassandra repository. The package simply had no installation candidate. Then we fixed Cassandra. The Elastic repository URL had a typo that caused DNS resolution to fail. And when we tried to download the app directly, the version numbers in the official documentation were outdated and returned 404 errors. We walked through each problem one by one, fixing the repo keys, correcting the DNS configuration, adjusting the Elasticsearch memory settings, and finally downloading the Hive using the correct direct package URL. The Hive is now fully installed, the service is active and running, and port 9000 is accessible from the Kali. Challenge 3, enterprise tool complexity. MISP, TheHive, and their integration are enterprise-grade platforms that require careful configuration at every step. We are following the official documentation closely, and each team member is responsible for understanding one tool deeply, so we are not all blocked by the same problem at the same time. So here are our next steps going forward. Step 1, the Hive installation is actually now complete. We successfully installed the Hive 5 with Cassandra and Elasticsearch, verified port 9000 is open, and confirmed browser access from Kali. So this step is done as of this milestone. Step 2, our immediate next priority is installing and configuring MISP on the MISP server. Once MISP is up, and we will connect it to AlienVault OTX as the external threat feed and import sample IOCs for testing. Step 3, once both MISP and TheHive are running, we will configure the bidirectional integration between them. The goal is that that when MISP detects a high confidence threat match, it automatically pushes an alert into TheHive and creates a structured incident case without any manual action from the analyst. Step 4, once the integration is working, we will run Operation Silent Invoice inside the lab. This is our full attack simulation, phishing, credential theft, lateral movement, and ransomware, and will capture how the CTI framework detects and responds at each stage. Step 5, finally we'll screenshot all working components, write the final milestone report with full evidence, and prepare the milestone 7 presentation. With the Hive now working, we are ahead of where we expected to be at this stage, and next team is focused on getting MISP up next. So to summarize where Group 3 stand right now, our VM is fully built and running. Our network is verified with 0 packet loss across all connection. Our requirement and framework design are complete, and our attack scenario is ready. Our immediate next step is deploying the applications like the MISP and getting the integration working properly. So thank you for watching this project update. I will look forward to your feedback.